morning students. Welcome to Oxford's online education classes. In this video, I am going to explain you about battery. Battery or cell. Cell is a single unit which converts chemical energy into electrical energy. If we combine these cells, combination of two or more cells is called battery. Now let us see how batteries are classified. Batteries are basically classified into two ways, primary cell and secondary cell. Primary cells are those which are non-rechargeable, whereas secondary cells are those which are rechargeable. It means primary cells are those which we will use in our remotes, TV remotes or AC remotes, whereas secondary cells are batteries which we will use in laptops, in computers, in mobile phones, etc. Again, these primary cells are classified into three types: galvanic cell, dry cell and alkaline cell. This galvanic cell is the oldest form of the cell, and in this galvanic cell electrolyte will be in the form of liquid. Because of this, galvanic cell is having a disadvantage, that is, whenever we use galvanic cell there are chances of leakage of electrolyte because it is in liquid form. That is why these galvanic cells are nowadays outdated. In order to overcome the disadvantage of galvanic cells, we invented dry cells. Dry cells, in the dry cells, electrolyte will be in the form of paste, that is, it will be in the form of a gel. And alkaline cells are cells in which electrolyte will be in the form of paste, that is, electrolyte will be gel electrolyte. In both the dry cell and alkaline cell, electrolyte will be in the form of paste, that is, in the form of a gel. Now difference between these two is, dry cells are oldest form of cells. These are oldest form of cells, and in this electrolyte will be acidic electrolyte. Electrolyte will be acidic electrolyte, whereas in alkaline cells electrolyte will be in the form of basic electrolyte. Electrolyte will be basic in nature. It will be basic in nature. It means pH of electrolyte will be greater than 7, whereas in dry cell pH of the electrolyte will be less than 7. Now compared to dry cell, life of alkaline cells will be more. Previously we have used these dry cells whose life is less than 2 years. Previously we used these dry cells whose life is less than 2 years, and electrolyte will be in the form of acidic. It will be acidic in nature, its pH will be less than 7. Because of this short lifespan, in order to overcome this disadvantage, again we shifted to alkaline cells. In alkaline cells, electrolyte will be basic in nature, pH will be greater than 7, and life of these cells will be greater than 2 years. That is nearly 2 to 5 years. Life of these alkaline cells is 2 to 5 years. The batteries which we use in present day is nothing but alkaline cells. These are again classified into three types: AA batteries, which we will use in our remote controls, AAA batteries and D cells. These are three types of alkaline cells, and these are classified on the basis of current delivery. How much current they are delivering, that is based on that these cells are classified. Example, if you take D cells will deliver large amount of current. They will be used in radios, whereas AA and AAA cells will deliver small amount of current. They will be used in remote controls. Now let us see secondary cells. Secondary cells are rechargeable cells. The batteries which are rechargeable are called secondary batteries, and example for these secondary batteries is nothing but the batteries which we use in our laptops and mobile phones. Best example is mobile phone batteries. And these secondary batteries, again they classified into two types: lead acid batteries and lithium ion batteries. Previously we used lead acid batteries. In this, electrolyte will be in the combination of H2SO4 sulfuric acid and lead chloride. This will be the electrolyte used in this lead acid batteries. And in these lead acid batteries, life of these batteries will be very less, and maintenance of these batteries will be more. In order to overcome this disadvantage, again we shifted to lithium ion batteries. Compared to lead acid batteries, lithium ion batteries, life will be more and maintenance will be less, and cost will be high. Cost of lithium ion batteries will be high, whereas cost of lead acid batteries will be less. Now these lead acid batteries, these lithium ion batteries, they have changed the fate of electronics. Previously if you see, we used to operate computers of very big size, nearly the size of a room. In order to operate such big size computers, we use very large batteries. In order to deliver such high currents, we use very large batteries. But nowadays, if you see, all these computers, they turned into very small size. For example, the laptops which you are using in nowadays. That is only because of lithium ion batteries. These lithium ion batteries, they will be in very small size, but they can deliver huge amount of current. By being in very small size, a small size lithium ion battery can deliver huge amount of current. Whereas the same amount of current, if it has to deliver in lead acid battery will be of very large size. Compared to lead acid battery made up of lithium ion batteries will be very small size, and they'll be in very small size, and they can deliver very large currents. Recently, a chemistry professor from Japan University called Akira Yoshino. He is a chemistry professor from Japan University. Recently, he got Nobel Prize in chemistry for inventing these lithium ion batteries. These lithium ion batteries, definitely they have changed the fate of electronics by delivering large amount of current in very small size. Now let us see working of a battery. Before going to working of a battery, I'd like to revise the basics of electrolysis process. In electrolysis process, there will be an electrolyte, let us say it is NaCl, and there will be two electrodes, one is anode and other one is cathode. Whenever we pass electricity in this electrolyte, whenever we pass current in this electrolyte, then what happens? This electrolyte, it will get dissociated into positive and negative ions. NaCl will get dissociated into Na plus and Cl minus ions. These Na plus ions will get attracted towards cathode, and Cl minus ions will get attracted towards anode. It means here in this electrolysis process, entire electrolysis process, electrical energy is being converted into chemical energy. Now nearly battery works in a similar process. In the battery, chemical energy will be converted into electrical energy. It is nothing but reverse of a electrolysis process, but procedure will be nearly similar to the electrolysis process. See here, in this battery there will be three components. That is, first one is electrolyte, and second one is two electrode plates. There will be two electrode plates. And this electrolyte consists of positive and negative ions. And electrolyte will always exert a constant force on this positive and negative ions. Electrolyte, it will always exert a constant chemical force on positive and negative ions. It means, in other words, this electrolyte will pushes these positive and negative ions towards electrodes. Electrolyte will push positive ions towards this electrode, and these positive ions will get accumulated at electrode, and because of these positive ions, this electrode will get charged positively and it will become anode. It will become anode. Similarly, electrolyte will exert constant chemical force on these negative ions. Electrolyte will exert constant chemical force on these negative ions, and in other words, it will push these negative ions towards electrode, and these negative ions will get accumulated on the electrode. These negative ions will get accumulated on this electrode, and this electrode, since it is charged fully with negative ions, it will become cathode. This electrode will become cathode. Since all the negative ions have deposited on this electrode, it will become cathode. Now we have two electrodes. One is anode, which is full of positive ions, and another one is cathode, which is full of negative ions. And still electrolyte will try to push these ions, it will try to push the positive ions towards electrode, and it will try to push the negative ions towards cathode. And if you take any positive ion here, if you take one positive ion, and this electrolyte will try to push these positive ions towards anode, it means it will exert constant chemical force on this positive ion Fc towards anode. And as this positive ion, as it moves towards the anode, as this positive ion moves towards the anode, and this positive ion and this positive electrode, anode, is already fully charged with positive ions. Because this anode is already fully charged with positive ions, this anode will repel this positive ion. Anode will try to repel this positive ion, because positive and positive will get repelled. It will exert one repulsive force on this positive ion. That repulsive force is nothing but electric force. Let me explain you once again. Electrolyte will try to push positive ions towards anode, and it will try to push negative ions towards cathode. And this positive ion, if we consider one positive ion, this electrolyte will exert chemical force on this positive ion, and it will try to push this positive ion towards anode. But this anode is already fully charged with positive ions. That is why, since here there is more amount of positive and this is also positive, these two will get repelled, and there will be some repulsive force on this positive ion away from the anode, and this repulsive force is called electric force. These two forces, when these two forces, chemical force and electric force, when these two forces get balanced, then battery is fully charged, and this battery is in a new condition to use. That is, this battery is ready to use. In this way, battery will maintain constant potential difference between the ends. This is nothing but working of a battery. I hope it's clear. Thank you.